get our notes out too?
Yeah, we're gonna just do sample props. So in the back of your notes.
Yeah, like class.
Oh, Gregor, you're not looking for. Gregor is up first. Oh, you are. Yeah.
All right, we're gonna start on number 18.
I want to start.
Oh wait, are we in the what's that?
In the back of the PowerPoint are your sample problems.
I got my buttons.
Get your buttons ready.
Uh-oh.
What is the same button?
Really? I bet set myself so late.
Yes, I actually want to know that.
I am one of the least proficient people on earth.
What is the chemical formula?
I just said I don't know anything about drugs.
What's the formula for weed?
I just said I don't know anything about drugs.
Look it up.
All right, number 18 is not actually what we're learning today, but it's a little bit of carryover from yesterday. It says how many milliliters of 3 molar sulfuric acid, strong acid, one of the 7 strong acids, hydrochloric, hydrobromic, hydroiodic, chloric, perchloric, sulfuric, and nitric, to make 450 of a 0.1 molar sulfuric acid solution. Underline H2SO4 twice. No. So this is a dilution problem. We're just taking 3 molar of sulfuric and turning it into 1 molar of sulfuric. This is different from what we're doing the whole rest of the day. We're not reacting anything. I'm just adding water to it. The dilution equation is M1V1 equals M2V2. We are starting with a 3.0 molar solution. We're going to solve for how much of that we need. So that's going to be V1. We're trying to make a 0.1 molar solution and 450 milliliters of that. You can only do a dilution equation if it's all the same thing. You cannot do it in a reaction. This math only earns credit for diluting. Push your buttons.
I got I did it in 30 seconds. Crazy. Should be crazy.
Okay, so that means we take 50 milliliters of that 3 molar solution, add it to enough water to make 450. So same game though, water on the bottom, stuff on top, and then water to our 450. Okay, how many grams of calcium hydroxide? Calcium hydroxide is in the hydroxide group. That means it is a strong base. To neutralize for acid bases means reaction. They will not say react, they will say neutralize. 25 mils of nitric acid. Nitric acid is one of the 7 strong acids. Hydrochloric, hydrobromic, hydroiodic, chloric, perchloric, nitric, sulfuric. Okay. So we are doing a reaction. Calcium hydroxide, oops, plus, it's almost as bad as equals, nitric, equals. Can you finish it and balance it in 15 seconds or less? Ready, go. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
I finished.
Did I answer it?
You missed it. Oh,
I did do it wrong. That's okay.
How did you not know?
All right. When you see these problems, this is not your baby chem stoichiometry. We are going to be solving for all sorts of things, not just grams. This time we are, though. How many grams? So you need to write question mark grams under calcium hydroxide. You are going to have to keep track of your data. are needed to neutralize 25 mils of a 0.1 molar solution, okay? The trick to doing any solution problem is to start with volume. Tell somebody next to you, always start with volume. Ready,
Always
set, go.
start with volume.
Tell them to never start with molarity. Ready, set, go.
Always start with volume, never start with molarity.
25 milliliters over 1 times in a line. Milliliters on top means milliliters on bottom. There are 1,000 milliliters in 1 liter. Liters on top means liters on bottom. Our capital N molarity can be turned into a fraction. It means 0.100 moles for every 1 liter. So 0.100 moles for every 1 liter. When we are at moles, our next step is called the mole ratio. When we do the mole ratio, we do our unknown over our known. In this case, our unknown is our 1 calcium hydroxide, and our known is 2 nitric acid, which is a strong acid. Moles on top means moles on bottom, trying to get to grams, so I use something called the molar mass of our periodic table. So go ahead, push your buttons, and then push your buttons. Ready? Go. Oh. Let's skip 20. Let's go to 21 because I have to show something to you because I feel, never mind, I'm just going to do it. How many grams of sodium hydroxide, is a strong base, it's in the hydroxide group, are needed to neutralize 20 milliliters of 0.150 molar sulfuric acid, is a strong acid, hydrochloric, hydrobromic, hydroiodic, perchloric, chloric, nitric, sulfuric.
Who's not going to remember that? You'll have to.
Can you do it? 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3. Is it balanced right? Yeah. It's hard to like count backward and balance and all that.
I agree. Wait. I don't think so.
Yeah, 4, 4.
Why is it H2OH? Oh wait, I didn't see the other H2. My bad. Yeah, that's right.
H2O2? Are you kidding me? Because you can't have HOH.
Yeah, but it's H2OH. No.
Okay.
No.
Cation. How many grams of sodium hydroxide, question mark, grams are needed to neutralize 20 milliliters of 0.150 molar solution? I'm going to be super repetitive and say the exact same thing I said last time because it's going to help you remember. Always start with volume. Tell somebody next to you always start with volume.
Always start with volume.
Tell them to never start with molarity.
Never start with
20 milliliters over 1 times in a line. Milliliters on top means milliliters on bottom. There are 1,000 milliliters in a liter. If that conversion drives you nuts, you can always skip it. You never have to show me this conversion. Liters on top means liters on bottom. I can convert my capital M into moles per liter. So 0.150 moles per 1 liter. Once we are at moles, then we do our mole ratio. Our mole ratio is always our unknown over our known. So 2 sodium hydroxides for every 1 sulfuric acid. And then moles on top means moles on bottom. To get to grams, we use something called the molar mass. And go ahead and push your buttons. And then push your buttons. Okay, if I was a good teacher, I would have made these different colors because they look identical, but I know. But I'm not a good teacher, so need to grab the one that says NaOH. We're doing the silver, I'm sorry, we are not doing this, we're doing sodium hydroxide first.
So the one with the numbers starting at the top?
Yes. Yeah, yeah. What I have for you is 3 more stoichiometry problems. They don't all solve for grams because I got to show you we're on a baby chem and honors chem. We don't always solve for grams. Then I have 3 homework problems. That is the other sheet that mimic them. So they're the exact same type of problem with different stuff. So then you can use it as support and do it. Okay, so 25 milliliters of 0.350 molar sodium hydroxide are added to 45 of 0.2125 copper 2 sulfate. How many grams of copper 2 hydroxide will precipitate? You start by writing the equation and writing in what you know and don't know. Ready, go. This is a limiting reactant problem. This is because we have both of the reactants. We don't know which one's going to run out first, and we're solving for copper 2 hydroxide. So you need to do your fractions twice. Choose the smaller answer. Cross out the bigger answer. It's not a thing. Don't look at mine. Push your own buttons. Just look at mine to check. This is called practice. I think it would be hard to tell because the volumes and the molarities are different.
What's a molar?
32 plus 2.02. Okay, but we don't always solve for grams. This is not your baby chem stoichiometry anymore. What volume of 0.415 molar silver nitrate? Well, this sentence actually doesn't make sense. I think I'm missing a word. What volume of 0.415 molar silver nitrate will be required to precipitate as silver bromide all the bromide ion in 35 milliliters of 0.128 molar calcium? No, it didn't.
Just check the statistics.
AgNO3 silver nitrate. What this is saying is we're reacting silver nitrate with calcium bromide. So that's
Copper. What's copper? Copper 2. Copper 2. Good everyone. Copper.
right.
I don't know.
That's so fast.
I don't know. Maybe it's like teaching chemistry.
Well, for 16 years. And also, that's the third time I wrote it today. But also because when I write a 2 for a subscript, I automatically know this has to be a 2. I don't know.
I know what you mean, kind of.
Question mark. What volume? Volume is going to be liters. Okay, question mark liters. And I have 0.415 molar. And then it says I have 35 milliliters and 0.128 molar.
Wait, can't you just use the one?
I know you're going to want to. It would not be acceptable. You not earn the point because this is not a dilution problem. This is a reaction. Okay? Even if the mole ratio is 1 to 1, which it's not. But if it was, you still have to do a mole ratio. Okay, tell someone next you always start with volume.
Always start with volume.
35 milliliters over 1 times in a line. Milliliters on top means milliliters on bottom. There are 1,000 milliliters in a liter. Liters on top means liters on bottom. Now you need to be careful and watch. I'm talking about calcium bromide, so do not take the molarity for silver nitrate. Take your molarity for calcium bromide, 1.128 moles for every 1 liter. We can turn our big M into that. Once we're at moles, then we do our mole ratio. Our mole ratio is always our unknown over our known. So 2 silver nitrates for 1 calcium bromide. You're going to stop here. I don't want grams. Grams isn't going to get me to volume. So I don't need to do my molar mass part. So go ahead and push those buttons right now, and then I'll tell you what's next. Although you might figure it out.
We're multiplied by 8.
Molarity equals moles divided by liters. I know my molarity and I know my moles, so I can solve for liters. Do you see why I didn't go to grams? Because I need my moles and my molarity. So 0.415 equals 0.00896 divided by solve for liters. We call that cross multiplying. In this case, we would take the 0.00896 divided by the 0.415. Sometimes I do it backwards, and then I need to check. 0.0216. So the beginning fractions are the same. What if we had to solve for molarity?
Well, then you just put the opposite.
Pretty much, it takes 83 milliliters of 0.45 molar sodium hydroxide is a strong base. It is not hydroxide. Neutralize, remember that means react in acid-base problem. Hydrochloric acid is a strong acid. Hydrochloric, hydrobromic, hydroiodic, chloric, perchloric, sulfuric, and nitric. Make salt water.
Love salt water.
83.45. 235. What is the concentration? Concentration means capital M, molarity. So we're solving for molarity of the hydrochloric acid. This is a case that if you do not have your 1-to-1 mole ratio, you will not earn the point because you're not actually converting to the hydrochloric acid. The math will be the same as M1V1 equals M2V2, but you can't do it. Always start with your volume, but choose carefully because you need a capital A conversion, so start with your sodium hydroxide. Otherwise, you'll get stuck. 1,000 milliliters in 1 liter. Liters on top means liters on the bottom. We can convert our capital M into 0.45 moles per liter. And once we are at moles, we must do a mole ratio because I need to convert over to HCl. Even if it is 1-to-1, we need to show it. Otherwise, our units are not correct. And that matters for a point.
You said that matters for a point.
For a
Are you
point.
talking about the AP exam?
Yep.
And you need 50 points to
Just making
pass.
sure.
53, I think it was last year. But yeah,
Is that a 5?
They're like
3.
What's a 5?
83, 84 usually.
Yeah,
That's really high.
It's about only 5 to 8%, depending on the year, of the world's population.
Well, that's
It's very low. Sure. Okay, push your buttons.
How often do kids get by from their stuff?
How many did you have?
Last year 4.
How many people got
So that's like
fours?
less than the 8%.
Yeah, our 5s are less, but our passing rate. I have been state champion until this last year. I got beat by Cedarburg. We are the highest achieving AP chemistry class in the whole state.
As far as
Except for last year, not this last year, but the year before that. Cedarburg.
Does it have to be in liters?
Molarity equals moles divided by liters. I'm solving for molarity this time, but I know my moles and I know my liters, kind of.
Nearly. Almost there.
Do you see? The 1 year where I taught Menominee Falls kids too, they open enrolled. We did so bad. They all got 5s except for 1.
Right there. Oh yeah, that's because it's like this one.
It skewed my statistics so when I